So hi, everybody. I am really glad that we can be back and that we have so many new people, because I do think today is going to be a great day for you guys. So we are going to be going through part 2 of our CDM workshop. But as I was putting this together, I realized while we subscribe to Greek ideology and not Roman, it is the Ides of March. So just beware if we think of the OHDSI Community Call as our Senate. Not that anything's going to happen, but just made me think about it. All right, so let's get going. All right, so like we talked about last time, we are focusing these 2 days on the journey from data to data, or more specifically from the journey from our patient level data in our source system to our standardized data in the common data model. So last time we went over our technical considerations for setup by Frank DeFalco. We had Kristen talk us through what we need to consider for data governance. And then Maxime walked us through structurally mapping our data using White Rabbit and Rabbit in a Hat. So today we're going to go through the OMOP vocabulary, and it's not going to be redundant as to what is going to be presented next week. This is really about OMOP vocabulary and how you map your data, how you map the content of your data, not as much structurally like Maxime showed last time. I'm also going to take you through data quality procedures that we've developed as a community. Anthony Molinaro is going to share with you our characterization tool, Achilles, and how it can help you better understand your data once it's been converted to the CDM. And then we're going to hear from Frank again, and he's going to put all these pieces together we've talked about the last few days, and he's going to give us a really nice demo. So because of our demo, I don't have interactive slides today, unfortunately, but I did save those questions from last time, and if you have any other questions, please put them in the chat. And we will respond as we go. All right, so here we have all of our speakers today, and we're going to get started with Melanie. So Melanie, I turn it over to you.
Great, can you hear me?
Yes, I can.
Awesome. Perfect, thank you. My name is Melanie Philofsky, and I lead the Healthcare Systems Interest Group, and I'm going to discuss the OMOP vocabularies today. Next slide. So we're going to discuss the who, what, when, why, and where of the OMOP vocabularies. How does it all work? We're going to discuss custom semantic mapping. One of the tools we use to do this is Usagi. And there's 2 different ways to do this, using the source to concept map table or what's called the 2 billionaires. And then we're briefly going to go over maintenance. Next slide, please. So the OMOP vocabulary tables, where they came from, who does all this work, what they are with a quick review of source code to concept identity mapping. How do you get these OMOP vocabulary tables, when you get them, and why do you need them? Next slide. So where do we get these vocabulary tables from? Most of the, or not most of them, some of these are in the public domain. Vocabularies such as RxNorm are already out there and freely available, so we incorporate those into the OHDSI vocabulary. We have also incorporated proprietary vocabularies such as the GPI vocabulary. If you have these codes in your source data, then you have a license to use them, and you can ask your institution for that license, and you can get these vocabularies. We also have some homegrown OHDSI concepts or OMOP concepts. One of these is the RxNorm extension vocabulary, and as the name implies, this is an extension of the RxNorm vocabulary to incorporate the non-US drugs into an extension. So that way it follows the same hierarchy as the RxNorm vocabulary. There is an OHDSI vocabulary team dedicated to updating and maintaining these OHDSI vocabularies for us. The thing to note on all these OHDSI vocabularies is that they have different release cycles. So all these OHDSI supported vocabularies such as RxNorm, NDC, they are released by the source on various different release cycles. Most of them are on a set schedule of 1 or more times a year, and there are a few vocabularies that have ad hoc releases. Once the source releases these new codes, the OHDSI vocabulary team ingests them and creates concepts with all the attributes. From there, they map them to the standard concept IDs, and this is a continuous and ongoing process. The OHDSI vocabulary GitHub page is the place to raise any issues or any requests for incorporating new vocabularies. Next slide. So, when should you download them? Now's a good time to download them because you can't properly populate an OMOP CDM without them. And if you don't have a populated OMOP CDM, you can't participate in any type of OMOP research, network research, and the OHDSI tools such as Atlas aren't usable without these CDMs or without these vocabularies to back them up. So next slide, go to athena.ohdsi.org and click the login button. You fill out the registration form if you're not registered. Once you log in, you can click the download button and then you select the necessary vocabularies. If it is a proprietary vocabulary, something that says it needs a license, then Christian Reich or someone from the vocabulary team will send you an email asking you for a copy of that license. Just email them back a copy of the license and you'll be able to download all the vocabularies along with all the relationships from your source codes to your concept IDs and your standard concept IDs. Once you send in the license, you don't have to send it in again, and you can just go to Athena at any time to download the more recent vocabularies. Up in the right-hand corner of the screen, you will see a little question mark with a circle. So next slide, please. You click on that, and that will bring you here. And this is the page that will let you know what vocabulary version you're on. It's a good thing to know that the vocabulary version does not align with the CDM version. So you don't need to try to match these up. Right now, the OHDSI community is on, or most folks are going to CDM version 5.4. As you'll see here, the OMOP vocabulary version is 5.0, and it was released on the 4th of February, 2022. You can also find this information of what vocabulary you're on from your source vocabulary tables. And you always want to make sure that when you're collaborating with others that you are all on the same version of the or using the same version of the OMOP vocabularies. Next slide, please. All right, so the OMOP standardized vocabulary tables include all these tables here. Now, the tables on the left-hand side of the screen, these are the ones we use for ETL and research. And these include the concept table, concept relationship, concept ancestor, and sometimes the source to concept map if that's being used for custom mapping. The tables on the right support the ones on the left and have the fully specified names and other attributes for the tables on the left. Next slide, please. We're going to do a quick review of the concept relationship, and concept ancestor table. So all the content of a concept is in the concept table. It's the concept, it's the source code, the vocabulary, and other attributes. The concept relationship table has all the direct relationships. So these can be parent-child relationships, or even more importantly, these are the equivalency relationships. These are how you use the concept relationship table to map those source concept IDs to your standard concept IDs so you can participate in research. And then the last OMOP table here on the right-hand side is the concept ancestor table. A lot of times these are called the hierarchy tables, and that's because in this table, it has all the hierarchical relationships, and these are used a lot by researchers to find drugs of interest if they want to use like a ingredient, and then find all the drugs that contain a certain ingredient. And they also are used when you're looking at condition and diseases of interest. You can come in at different levels within the hierarchy and then find all the children of that. Next slide, please. So there are different, what I like to call categories of concepts. So we have the non-standard concepts, and these are the unique representations of your source code. It is a source code and the vocabulary ID, which gives you that source concept ID. Then we have the standard concept IDs. Sometimes your source code is represented by a standard concept ID, and sometimes you have to map from your source concept ID to your standard concept ID. The standard concept IDs are used in analytics, the research, and by the OHDSI tools, especially Atlas, to find cohorts of interest or concept sets. Then we have classification concepts. Sometimes people call these groupers, and these don't directly represent a row of source data, but they are groupers or classification concepts that contain all the children of an idea. And we use these to perform hierarchical queries or to set up a concept set. Next slide, please. So your source for source code. The first three are use OHDSI supported vocabularies, right? So the first one may come from an international terminology or coding system, such as SNOMED or ISBT. Your source code may come from a country-specific terminology or code system, such as the READ codes, ICD-10-CN, CVX, or BDPM. Sometimes your source code or source value may be free text strings. We see these a lot with the units for vital signs, the routes for drug administration, and also some of the social history and lifestyle context, such as cigarette smoker. Then we also have some proprietary, or not even proprietary, these are custom code systems within your electronic health record, your case report forms, registries, etc. These are specific to your institution or your data source, and you'll only see them there. Next slide, please. So mapping your source codes to the concept ID. So you always map to a standard or a non-standard concept IDs. You do not map to the classification concept IDs. Those are only used outside in the vocabulary tables for research to gather concepts of interest. So if your vocabulary is known, you use a combination of your source code and the vocabulary ID to retrieve your concept ID. Sometimes the vocabulary is unknown, such as with routes of administration or the units for vital signs. However, in these cases, you know the domain. So you use the combination of the source code and the domain ID to retrieve your concept ID of interest. And then sometimes you have your custom local source codes, and these need to be mapped to standard concept IDs. And we'll go into a little bit of this in a minute. So next slide, please. So scenario one, when you have a source code that comes from an OMOP supported vocabulary, use the following conditions to perform the mapping. You match up your source code and the vocabulary ID to the concept table, and that will give you the unique concept identifier. You can see a few examples of that here. Next slide. If your source code is a text string, but you know the domain ID, it's the combination of that source string with the source domain to get you the unique concept identifier for that idea of interest. So you match those up, and as you can see on the right-hand side, you'll get your concept ID of interest. Now, our third scenario, next slide, please, is when your source data does not map to an OHDSI supported vocabulary. So there's two different solutions. One, you ask the OHDSI vocabulary team to incorporate your vocabulary into the OMOP vocabularies. They'll bring it in, they will take them, they will give them source concept IDs, and they will create the relationships and map them to standard concept IDs. Or if that's not possible, then you need to create custom mapping using one of the following two methods, either using the source concept map table or the 2 Billionaires method. Next slide, please. So for custom semantic mapping, There is a Java application called Usagi that is available out on GitHub, and I will post links once I'm done speaking here. I'll post all the links into the chat that I'm discussing today, so that way you'll have them at your fingertips. So you can use the Usagi application to help you map your local codes to standard concept IDs. And then you once you have those mappings, you can either use them in the source to concept map table, or you can use the concept and concept relationship tables. And then we're going to discuss when do you not create a custom concept ID. So next slide. Here is a screenshot of the Usagi application. You have to have downloaded your OHDSI vocabularies already in order to map those local codes. You take a CSV of your local codes and you upload them to Usagi, and then it will give you suggestions on mapping. You can narrow this down if you're looking at a certain domain. You map one domain at a time. So you upload a CSV of all your drugs or maybe all of your units. And then you configure it in Usagi to let Usagi know what kind of source data it's looking at. Once you have all your source codes mapped to standard concept IDs, then you can put them into the source to concept map table. So for this, we are going to use an example source code, a pediatric interventional cardiologist. So this source code is not supported by any OHDSI vocabularies. It's a local code, made up local code for an institution. So this is how you would map it to a standard concept ID using the source to concept map table. So you have the source code, which is just a free text string. There was no quote unquote numeric code to identify it. Then you give it a source concept ID, which is a unique identifier greater than 2 billion. The OHDSI vocabulary team has set aside all the numbers greater than 2 billion for use with local institutions. Then you give it a source vocabulary ID. This is another required field. And for this, we're just calling it provider specialty or prov_specialty. We have the source code description, pediatric interventional cardiologist. And then we're mapping it to a standard concept ID, which is 903276. And this comes from the vocabulary, the Medicare specialty vocabulary. We have a valid start date and end date for this mapping. And the invalid reason is null because this is a current mapping. Next slide, please. Next, we're going to discuss the 2 billionaires. We will create a concept and then we will create the concept relationship. Next slide. So using the same example, pediatric interventional cardiologist, we're going to create a record in the concept table. So once again, we give it a concept ID greater than 2 billion. We give it a concept name. The provider or the domain ID for this is provider. The vocabulary ID, we have a custom vocabulary ID, and this is provider specialty or prov_specialty. And we give it a concept class ID, a physician specialty, because this is a physician specialty. Standard concept ID is null because this is not a standard concept ID. We are creating a record for a source concept ID for this for the pediatric interventional cardiologist. We give it a start and end date. We just use the default start date, which is January 1st, 1970. And since this is a valid concept ID, we give it an end date in the future of 12/31/2099. Next slide. So next, we need to create a concept relationship record to map this source concept ID to a standard concept ID. So for the record number for the record we just created, it was 2.1 billion for the concept ID, and we are mapping it to 903276. All mappings within the concept relationship table are bidirectional. So you create a maps to relationship for your source concept ID to your standard concept ID. And then you also create the opposite relationship, which is mapped from. We give it the default valid start dates and valid end dates because this is a current mapping. Next slide, please. Here's a quick comparison of both the methods. So if you use the source to concept table, source to concept map table, this table is designed for insert statements. You will need to create an additional SQL lookup statement during your ETL because normally we look up the concept and the concept relationship when going from source codes to standard concept IDs. And then since you're using the source to concept map table, you'll just create an additional lookup at your source to concept map table. If you use the concept and concept relationship table or the two billionaires, you're going to need to modify the OHDSI provided tables. So you'll need to modify the concept table and the concept relationship table and then the vocabulary table. Using this method, it does enrich your vocabulary and it also enables the display of the source concepts in Atlas. So you will be able, your researchers will be able to see what source codes map to that specific standard concept ID that the researchers are going to use for their cohort of interest or in their concept set. And this method is also great for any type of internal use cases. If that pediatric interventional cardiologist wants to see like all the procedures that are done by that provider, they're able to do that. So that's a comparison of both of these methods. Next slide, please. When do you not create a custom concept ID? You don't do that when you have a new source code that is coming from a vocabulary that's already supported by OHDSI. So you may have like some NDC codes being used within your source system right now. OHDSI, it takes a little bit of time for the OHDSI supported vocabularies for these codes to be ingested by the OHDSI vocabulary team and then mapped to standard concept ID. So if it's going to be supported, if it comes from, you know, NDCs or one of the ICDs or something like that, you don't create a custom concept for this because this will be coming down the pipeline very soon through the OHDSI vocabularies. Or if it's a new vocabulary that has a very strong use case, say you just recently joined the OHDSI community and you have a lot of drugs from your national drug vocabulary, have a discussion with the OHDSI vocabulary team for incorporation of these codes. Next slide, please. All right, maintenance. So every time you update your OHDSI vocabularies, once you download those from the from Athena and you incorporate it into your CDM, make sure you rerun your ETL. After you've done that, you need to complete an analysis of your CDM, right? You want to review your top unmapped values, and you also want to review your data for any duplicates. Are any of those source codes now represented by an OHDSI supported concept ID? Once you do those two analysis functions, then you're going to update your source to concept map or concept and concept relationship tables as needed. Next slide, please. This slide is just a slide for all of the resources that I have discussed today in the tutorial. Craig always posts these to the OHDSI forums. Once the recordings are up, he will post the slides, so you can click on the links there. And then I'm also going to add them into the chat now. If you have any questions, just put your questions into the meeting chat, and I'll take a look at those questions and answer them as time runs. And that's all. Thank you.
All right, awesome. Thank you, Melanie. So I'm just going to give you guys a quick overview of our data quality processes that we've put together within OHDSI, but just as a reminder of where we've been over the course of the last few days. So we talked about technical considerations for setup, so how you would set up your server, where your vocabulary and CDM should be, like they need to be friends, they got to talk to each other. Maxime showed us how to scan our data and then map it structurally using White Rabbit and Rabbit in a Hat. And then Melanie just shared with us how we would map our vocabulary and then specifically how we handled those cases where there is not an existing concept in the vocabulary and we might need to create our own. So at this point, you would probably be somewhere around, you have your CDM, you've got your data in this standardized format, but it might be on its baby legs. Like it's new, we got to evaluate it, we got to look at it just to make sure that we've done what we set out to do, that we standardized it and that we standardized it correctly. And then we want to start looking at the quality of the content of the data as well. So we're gonna shift focus and talk a little bit about data quality and then data characterization. So I had a couple things just to share with you, like why it's important. I'm not going to go through these, but these are from regulatory agencies, FDA and EMA. Just know that they are really keen on data quality, especially as they want to start making more decisions based on real world evidence. Think Darwin EU. So this is important not only for the ETL process, but also later on down the line as we want to scale up our evidence generation, we have to prove we've gone through the due diligence of assessing our data. So we're in a bit of a unique situation, I think, when we talk about data quality related to standardized data, because we have to assess the quality of the conversion, meaning, did I get my data from point A to point B correctly? But then we also want to think about the quality of the data itself and the content of the data. So when we put together our OHDSI solution, we had an eye to both of these things. Now, I'm not going to go through the tool in completeness, but just know that the way we put this together is that we rely on the standardized structure of the CDM to help us generate on the fly individual data quality checks. And we do that by defining these higher level data quality ideas or check types. So not an exhaustive list, but these ones here are ones that evaluate our conversion of the data. So did we follow all the ETL conventions? Did we walk through from source to standard correctly? So things like, does every person have at least one record in one table, even if that table is observation period? Are all the unique fields, do they have unique values in there? Are all the concepts in the condition occurrence table, are they all in the condition domain? All these things that we expect when we start to use an OMOP CDM, we can use this tool, the data quality dashboard, to check those items. So that's what these checks are doing here. And then on the flip side, we want to look at the quality of the data itself. So that's what these checks do. Something like plausible temporal after, all that's doing is saying, are all your visit end dates, do they all occur after your visit start dates? And most likely, that would be something coming from the source data rather than an artifact of the conversion to the common data model. So that's where you might go back to your source data and say, hey, what's going on here? Do I have an issue? And try to address it at that point. So we've got these 20 check types, just showing you quickly. They fall into these categories. These are defined by a paper by Michael Kahn, so I'm happy to share that with you guys if you're interested, but in the interest of time, I'm going to skip over that. But just know that our tool, as we've defined it, overall evaluates like 3,100 checks at this point, but the team is working hard to add more this year. And if you want to check it out, it's on GitHub, just data quality dashboard, all one word. And like I said, the team is working very hard. We just released version 1.4 with full support for CDM 5.4. So well on our way for that. And just a little note, if you wanted to just explore the output of this tool, which is a Shiny application that you can click through and see all the different checks that it evaluates, we have an example out on data.odyssey.org. You can see the link at the bottom. I will share that as well if you just want to get a feel for what the tool does and what the output looks like. And we have a paper as well if you wanted to dive even deeper into data quality, because I know you guys, like I, love data quality and want us to have the best data possible as we are expanding our reach around the globe. So that's it for me. I'm going to hand it over to Anthony, and he's going to take you through Achilles and how we can explore our data even further through characterization.
Yes, can everyone hear me? Yeah, okay. Hi, I'm Anthony Molinaro. I work with Claire and Frank at Janssen, and I'm going to very quickly, so I can give Frank 5 minutes to speak, discuss Achilles. Next slide, please. Okay, before I explain what Achilles is, it's important to understand where we are in the ETL process. So Achilles will be run after your CDM is built. Now, Claire just presented a quick overview of DQD, and it's important to realize that Achilles does not depend on DQD being run first. These are two tools that operate independently of each other. Next slide, please. Okay, so what is Achilles? Achilles is an R package, and you can find it on GitHub. And I'm going to show you the results of Achilles using a tool built by our very own Frank DeFalco called Aries. And it's an R package for data characterization and quality. Now, we have a tool Claire just discussed called the Data Quality Dashboard. And we're purposefully equivocating on the word quality here, because whereas the Data Quality Dashboard allows you to perform a quantitative assessment of your data, here, Achilles enables you to perform more of a qualitative ETL validation. And it allows you to look at the evolution of your data over time in a way that's not so easy to characterize with predefined explicit checks. As far as characterization goes, for those of you who have been on these calls before, you know that the OHDSI community is on the cutting edge of methods research, in particular when it comes to study design, prediction, and effect estimates. But however, as Patrick has mentioned many times on these calls, crucial insight can be gained from characterizing your database, specifically pre-computed aggregate statistics run on your database that enables you to quickly answer questions. And this is how we're going to use Achilles. If you have very small data sets, you can do this with an Excel spreadsheet, and this is trivial. But if you're dealing with millions of people, billions of rows, and dozens of databases, now characterization becomes a non-trivial task, and a tool like Achilles is very, very important. Next slide, please. Okay, so we're just going to jump right in and see how we could use Achilles as a tool to simultaneously learn about your data from an overall database perspective, and to enable you to perform a qualitative validation of your ETL. Okay, so this is a screenshot of Aries, and we've picked the IBM CCA database. And if you look at the upper right-hand corner of your screen, you're seeing we're looking at something called the data density report. The x-axis of this plot gives you the time, you get the year, and the y-axis gives you a record count by domain. So this is a great first check to run after your CDM is built. Why? You can look at the evolution of your database records over time. Year after year or release after release, is your vendor providing you more data? Is there normal fluctuation every quarter, every year? If you jump on over to 2020, perhaps you had a global pandemic and the healthcare utilization decreased. Well, then a dip across all domains in terms of record count is expected. This is a great way to see if there is data loss or a change in your ETL or a change due to a change in your ETL logic. Next slide, please. Okay, we started with domain record counts. Now we're going to drill down further into that. If you look at the top of the screen, we're looking at something called a person report. And here are very, very simple questions that you want to be able to answer very quickly. How many people does my database have? What is the gender breakdown? Suppose you thought that your database would look similar to the United States Medicare database. Well, you might be surprised by the bottom of your screen because we have people born after 1960, let's say. So this is a great way to see very quickly if you have the expected number of people in your database, a gender distribution, and age breakdown. Next slide, please. Okay, so we went from domain records to people. Now we're looking at visits. You are executing a study and you want to know whether or not your database supports emergency room visits. Well, if your database doesn't have any, it would not be a viable database for that study, however good the database may be. So here's this visit occurrence report is a very nice way to very quickly see what kind of visits the people have in your database. Next slide. And this is the last one. Okay, so we started from domain record counts to people to visits. Finally, we care about events. Your studies are going to look at certain events, perhaps a drug or a certain procedure. Here, we'd like to know this new database I'm looking at, does it have any patients with COVID? Well, you can enter it. I put in the string COVID-19, and I quickly saw that it was mapped to a particular concept ID. And there was over 1.5 million people with this condition concept. And on the bottom of the screen, you could see this plot. The two bars represent the interquartile range. And if I just put it here in a picture, but if you mouse over it, that little table beneath will pop up and you can see the min and max values and the percentiles. And so you see very quickly that using Achilles in conjunction with the tool to visualize the results will enable you to understand what your database looks like, how it has evolved over time, and quickly answer very, very important questions as to whether or not your database is appropriate for use for a given study. If you have more questions regarding Achilles or Aries, you can always post your questions on the OHDSI forums. Frank and I are both pretty active on GitHub, so you can use the GitHub issues or the discussion tab on either Achilles or Aries. That's it. Thanks.
All right, thank you, Anthony. So now we've got 3 minutes left. So Frank,
Sorry,
bring it home. Break out that demo and show us what you can do when you put it all together.
So it's going to be awfully difficult to do very much in 2 minutes, 38 seconds. But what I want to share with everyone, and I will try and share my desktop quickly. Are you able to see my screen now?
Yes.
Yes.
Okay. So I'll throw this into the chat when I'm finished. In order to be able to run through all of the things you've heard across the 2 different sessions of us discussing this data operations pipeline, to be able to go from I want to take my data, ETL my data, leverage the vocabulary, characterize my data with Achilles, evaluate it with the data quality dashboard, and then review it in some magical way. I want to make that something that everyone is able to do. So a script that I use in order to facilitate that work is something I'm sharing as what's called a gist. If you haven't heard of a gist before, it's simply and now I'm not able to switch over to my gist. So it's a sample set of code that's up on GitHub. And so I will post this link when I'm finished. What the code has for you is a easy way to go through and provide a way to generate 4 different data sources to create your own local network. It will use a tool called Cynthia to simulate data. And you can see here I'm simulating data for New Jersey, Pennsylvania, New York, and Delaware. I apologize for my Northeast bias. The data is simulated, creating 250 individuals each. We then create schemas for our local CDM. We use the packages we heard about in the first session where we use ETL Cynthia leverages the common data model package to build our tables, to load them, to leverage the vocabulary, which you heard Melanie discuss today, to then load running the ETL, all the data into CDMs, to run Achilles, creating all of our database characterization, to run the data quality dashboard, to generate our data quality results, and then to export all of those results, throws in some temporal characterization for those who find temporal characterization fun and interesting, and then build all of this into a index that you could then go and view, visualize, leveraging areas, which Anthony was showing briefly today. So we're at time, so that's about all I can say. But I will drop this link into the chat for those who are interested in either making use of it or collaborating on its development. Please do let me know, and I hope this has been helpful.
Yeah, absolutely. So thank you so much, Frank, and thank you all for sticking with us. We are going to be setting up additional CDM workshops outside of the community call, so we don't want to torture you any further, but they will be individual meetings on each one of these different topics. So if there was something that you wanted more information on, we'll be sharing that and putting those together for you all.
Great, Claire. Thank you so much. Thank you to everybody who joined. Special thanks to Claire and Melanie and Anthony and Frank for this session. Jam-packed, obviously. Sorry we couldn't get to Frank's full, but future CDM workshops, please look into those. We'll have more information on them when they're available on these community calls. Thank you to everybody who joined. The full video will be on the community calls page later, as well as last week's. We'll put it all together so you have the full workshop. Thank you everyone for joining, and we will see you next week. Bye.